Good afternoon, everyone. I can see a 3/4 filled room. I know it's the end of the day, but I've got a bunch of interesting folks here. Someone who completely disagree with each other on the topic of machine learning. And it's interesting. We just spent 5 minutes before the session, and we pretty much got into argument mode in those 5 minutes. So I think it's going to be a lively session, and I mean, with no disrespect to some of the previous panelists who kind of added on to whatever each other was saying. Here, you're going to find a lot of contrarian views. So I got introduced. I'd let the panel introduce. Muddu, if you can start with.
Thank you. Thanks for having me today. Good afternoon, folks.
Afternoon.
That's it. Only one person shouting. Pari, you need to get maybe more coffee or more sugar here, or more cannabis. In California, it's legal. All right, folks. So my name is Muddu Sudhakar. Right now, I am CEO of a company called Isera. It's a startup company, still in stealth mode. Before that, I was at ServiceNow, and before that, Splunk, VMware, etc. So I usually a CEO in a startup companies or big companies. I play senior VP, general manager role. Look forward to talking to the panel today.
Hi there. My name is Soma Velayutham. So I'm actually from the telecom industry, and I moved to NVIDIA slightly less than a year ago. So if you look at my background, my first half of my career was in Bell Labs Technical, and then later on with Nokia Networks. I helped build multiple businesses for Nokia Networks as an entrepreneur, and then now I'm working with NVIDIA in AI and deep learning, trying to incubate a vertical within the telecoms industry.
Hey, my name is Siddharth Ram. I am a fellow at Intuit, and I've done a number of interesting things there. Right now, my focus is on our ML platform, infrastructure, our cloud migration, and scaling large distributed systems. Those are the 3 areas I spend time on. Prior to that, I was the chief architect for the division. So right now I have a slightly more focused role. And prior to that, actually, I helped start up some of the first machine learning based products at Intuit. And prior to that, I was at a couple of startups, had my own, and spent a number of years in the telecom area working at Qualcomm.
Hi, good afternoon, everyone. I am Sunder, one of the founders at Sahaj Software. Primarily do tech advisory and consulting work, and in addition to that, Sahaj also does custom software development. So unlike my rest of the other panelists, have not researched deeply into ML and AI, but we do help some of our customers with data engineering and adopt ML techniques to get better at their business.
Yeah, so we have 4 distinguished panelists here, and that reminds me of 3 gentlemen. A cryptocurrency expert, a guy who was doing deep learning, and another guy who's doing statistics. So these 3 guys walk into a bar in faraway Dublin. Do you know what happens after that? Facebook buys them for about $42 billion. They buy the bar for the $42 million. So the theme here is machine learning CoEs, which is centers of excellence, and how do you build these inside organizations? Pretty much everyone wants to do something around software. I heard one of the earlier panelists talk about how every company needs to be a software company, which is very true. But then machine learning is something which everyone wants to do. It's real and now. How do you get along that journey of building an organization that understands machine learning? What are the challenges that typically these companies would face? And the gentlemen here have all been there and done that. And my questions towards these guys are going to be, essentially around how do you do that. So I'll start off with Siddharth. Siddharth, you've been in Intuit, and for a long time, you built that entire AI and ML organization. So can you relate your experiences in terms of how did the organization start on an AI journey, and what does it take for a org to start on that? What kind of business challenges do you pick up?
Yeah, sure. If you're familiar with Intuit, and we have products like TurboTax and QuickBooks. So everything at Intuit starts with the customer, and really I think one of the biggest mistakes any organization can say, oh, there is machine learning, we need to adopt it, but why do you want to adopt it? So till you connect with a customer problem, you're not really going to get the business outcomes that you want. So I'll kind of share the story of one of the early products that I actually helped incubate. And that was the customer insight that we had, and we have had for a little bit of time, was that, and the numbers are somewhat startling. In the small business area, we serve small businesses. Small businesses have a shocking failure rate. 70% of small businesses will go out of business in 5 years. And a huge part of the problem, that the reason they go out of business is, some of them obviously, they didn't have the right business model, didn't do the research, but a big part of it is access to money. So if a small business goes to their neighboring banks and says, I need a loan because I'm starting this business, the bank looks at them and says, I don't know who you are, so what I'm going to do is pull up your credit report and make a decision based on your credit report, and why don't you come back in 60 days or 90 days and I'd let you know. So the thing we are trying to solve was, we are trying to come at it from a completely different angle, and we said, if you're a small business and you're using QuickBooks, we actually have access to your information about how your information is doing. And rather than look at your personal credit reports, we're going to look at how your company is actually, how your small business is actually doing. And we'll actually make a decision based on that. Now, if you go to a bank will say, we need 2 years of history before we'll make you a loan. We make loans with people who have had 60, 90 days being in business, because we are confident in our ability of using ML to kind of predict how a small business is going to be doing. And while a bank might take 60 to 90 days to actually fund your loan, we turn it around in 24 hours, right? So a lot of what we have done through machine learning has actually allowed us to serve our customers a lot better. So we started with a clear sense of what the customer problem we want to solve is, how we are going to use ML, and how we are going to experiment our way into a solution. And at this point, we don't share the numbers on this, but this is an incredibly fast-growing business, and our default rate on loans is significantly lower than what the industry average is, in spite of having lesser data, quote unquote, to go on. So that's an example of how we approach it.
Yeah, thanks, Siddharth. Muddu, to Siddharth's point, right? When you start on that journey, obviously you need a lot of talent, and talent is scarce, especially when it comes to a field like AI and ML and any of the algorithms around that. You've built and sold companies. You spent a lot of time in this industry. On the analytics side, on the AI/ML side, can you narrate some experiences around what are the do's and don'ts of, getting talent, and do you have a contrarian view on this?
Sure. Look, if you just bubble up the discussion that the panel is supposed to be talking today, right? So my view is a little different. Again, everybody could take different views. My thoughts are following in this way. Look, I think if you step back and say, why is this age is going to be any different than 30 years back or 40 years back, right? If you build organization like Wipro, you guys did it, or Zenov, Paris built organizations. So I think what machine learning age will teach us that different is, ideally you want to create a software where it actually replaces the data scientist himself, right? There's a whole new movement right now happening called auto ML. So I think, how do you automate process where you can do more with less? Because this new way of doing software should be, you want to develop models which will write itself. Why does the whole Go algorithm from Google got all the attention was, it's not because the algorithm was written by a data scientist. The model itself wrote the new source code and executed against the Go player the next day. That is if you do this thing, actually, I usually talk to people saying that the Turing, Turing person who invented the whole Turing machine, he'll come out of the grave. The whole Turing philosophy will fall apart at this point, right? You don't need any more the Turing tests if you can do it this way. So if you now understand what that means to building the teams, is I've tried various philosophies. So most data scientists today are ML people. In my perspective, when I look at them, they're good, but I really need a data scientist who, whether he or she can write code. Without software, if you write a model, whether it's written in Python, R, doesn't matter what language or what you write, it's useless. Earlier we were talking about this, again, this algorithm has to be parallelizable. If it's going to run on a single node, whether in a single CPU or single GPU, it doesn't matter. Even the GPU itself may scale parallelly. I'm looking for people who can take cloud scale example, can parallelize these algorithms. That means any algorithm that's written, if it cannot be parallelizable, I'm not interested. So if you take that philosophy to at scale, what happens is that how you want to build the organization is, if you have X number of people in data science, what I've seen over the last 8-9 years is you would need almost 4 to 5x data engineers to keep every one person of a data science busy. That means if you have 20 data scientists, you need to have 80 data engineering, data platform people to keep it. What do? Your mundane task, your ETLs, your feature extraction, your parsing, getting the data organized, making sure the data is going through a proper messaging bus, and making sure these models are waking up and training themselves, right? All that work actually takes 4 to 5 people for a single data scientist, whether that person is a statistical ML, Markovian algorithm, probabilistic algorithms, deep learning, it really doesn't matter, right? So that's one philosophy. The second philosophy in building the teams is, the models and algorithms are actually worth zero. What I really care is data. So if you look at it, why is Google to OpenAI, all these guys are releasing their algorithms to the wild open world. It's not that they're trying to do a good service to us. There's a fundamental reason why they're releasing it, because the algorithms are useless without a data. Nobody has data. Most often, like Siddharth is talking about Intuit, they have the data. They're able to do a better job than a banks because they know the behavior of their SMBs. That's the greatest example you talked about. So without data today, you cannot do anything. So if I can collect customers and people who can generate the data, they're more valuable to me than a programmer or a data scientist. So companies are now gone to the other extreme. So today when you start a project, I don't want to hire anybody actually. I actually want to collect the data first. I want to hire programmers first who can actually cleanse the data, organize the data that I can make sense out of it. Then comes you hire your AI ML people, right? So that philosophy has changed a lot in last 10 years. Before, if somebody can do mathematics PhD or physics PhD or he can do computer science PhD in machine learning, you'll hire them, hoping that he or she can write anything, right? So the fundamental shift is that the algorithms are just a value. Without data, they actually cannot surface a value. Second thing is, you need more data engineering people who can actually create a product than the model themselves. The last thing is, if you want to take all these things, somebody has to fine tune all these algorithms. So typically, if you take a version 1 of a product in this AI and ML, it takes almost another 4 to 5 years for it to be stable. You got to fine tune every parameter. Who is going to do it? Do you think you'll have your data scientists fine tuning each of the neural net weights on each of these nodes and do the reinforced learning and take the feedback and do it once a day or once a week, right? Look at all the companies which have done in this area. There are like 3-4 areas, right? Whole ad tech went through this machine learning. E-commerce went through this. Cybersecurity industry went through it. Now you are seeing entire cloud, AI ops, fintech is going to go through this. So what these guys have learned is this manual fine tuning will cost millions or billions of dollars. So the next evolution is what a lot of these industries call auto ML. How do I do parameterization, everything in automatic manner? I don't want to use a human being. I don't want to use a programmer. I don't want to use a data scientist for this. So these are the 3 dimensions in which you want to think about really building the products and companies.
No, great point, Muddu. I can see, Sundar nodding his head in agreement and also disagreeing on some aspects. He was smiling at times when, so I'd like Sundar to add.
Yeah, I think you made quite a few observations and points, Muddu. So I think I agree with some of them. And I think some points, I think we'll probably need to take it with a little bit of a caution, because it's always the data is very important. Today, a lot of businesses, especially enterprise businesses, deal with scarcity of data which is incomplete, because legacy systems, we've always been used to saying that, okay, let me store the eventual end state of the transaction. What happened in between, why something happened, and all of that stuff we never used to store a few years back. So the context information is missing. Second, the data is incomplete. To be able to do any of these inference engines or models to be run on it. Third is, there is also multiple instances of data being overloaded. Data has the same particular attribute, has different interpretations in different contexts, which is all hidden in programming logic and code, because people did not want to update their data model when they were implementing a new feature. Now, in this kind of a scenario, I think running any models or being able to come up with any predictions on this kind of data is going to be not very helpful. So I think one of the first steps should be that one needs to sort of change their systems in a way that it's no longer a system of record, but it is also a system of context or a storage of context. Second is that I think from an evolution perspective, take it a little slowly of deriving inferences and recommendations out of it before feeling confident and saying that I'm going to take decisions on the day based on the models.
So I agree with your first point. That's what I was saying, right? So my point is same thing what you're saying. It's garbage in, garbage out. Somebody has to do data. But I don't agree with the second one. Look, I don't think the world wants to wait us. In our lifetime, we are going to see driverless car. Granted, somebody actually died in Phoenix the other day, right? The mistakes will happen. But the point is, I don't believe in just slowly walking before you run. I mean, Elon Musk doesn't believe it. He's trying to send the rockets back and forth doing it. Look, I think you need to put your engine, get at some point your kid, you teach him whatever it is, then gloves are off. Let the kid go out of their house. If he gets beaten up, it's beaten up. That's how you'll know if machine learning is working or not, right? I mean, how long do you want to do babysit and start spoon feeding your algorithm and trying to do that? I don't like that model. Like, write an algorithm, put it in the wild west, let people beat it up. That's why you have the open source foundation, let people take advantage of that.
I wouldn't completely disagree with you, but the thing is, I think I would rather put it that it is dependent on the business context and the domain that we are operating in. See, for example, someone were trying to do the same thing on oil and exploration and investing billions of dollars based on some analysis. It's going to be, the risk of failure is very, very high. Same is the case with healthcare. Now, we see a lot of adoption of ML and all of that stuff in the content world, in the e-commerce world, in the image classification world. But the same algorithm, when we take it to healthcare world, the risk is very, very high.
I disagree. I think back to your oil and gas companies, why should they? I mean, first of all, any error you make, it's still a small error margin compared to the billions of dollars BP is making. So there's no risk in it. I mean, I'm a shareholder there. I'm making plenty of money. If they can take more risk, it's fine. Same thing, healthcare. Healthcare is the reason called laggard. So they can't run any more faster. They can run some more faster. I mean, as Vinod Khosla called it, like replace the doctors. Do you think what is going to happen? Do you think doctor can decide better than an algorithm today? Let's try it, guys. I mean, come on. We have worked enough for 100 years, so let's run now.
I think as technologists, we probably feel a lot more confident to actually take that stand, but I think as regulators and governments, they are.
We cannot. It's up to the regulators. At least we as a technology, we should do our job. We should not be saying, look, let's play the regulator role. We are not regulators. Let regulators come and put it. We should be saying, put it out there, throw the system, run it faster. I don't want us to be playing the regulator role.
So well, you do need to be careful about
that's right, responsible technologist.
False positives and false negatives and things like healthcare that can have a significant impact. Sure. That you can't really throw things out there, right? In my mind, the real model when you apply to healthcare is how do you make a radiologist better and think less about are we going to get rid of the radiologist altogether? That is probably going to happen, but in the meantime, a radiologist can be a lot better because they're actually getting, ML is acting as an aid to them as opposed to trying to replace them.
But this is where I disagree. I think, look, you can have both opinions true, but my thinking is different there, I think, Siddharth. So I think most often today, ML, most people think saying that it's going to be an augmentation game, whether it's in radiologists, whether it's in doctor, whether it's in IT operations. Like I give the famous example, in DevOps and IT ops, how many people are you going to have? Are you going to have your algorithm trying to help an IT admin, IT ops? I mean, imagine every department, IT operations is like the largest bill. They'll have thousands of people. You are going to get your trading is happening automatically for your pension trading. Your cars are driverless, but when it comes to your IT, you want to have a human being watching the monitor and make a decision. It doesn't make sense to me. There's no augmentation there. You got to really replace things. So I think this is where you have to decide. Do you want your algorithms to replace? This is where the digital transformation is happening. Do you want to do arbitration? I call it labor arbitrage. Or do you want to take that bet? Do you want to do a digital transformation, a fundamental disruption? Right? Or do you want to send a rocket where with a human being inside and trying to pour coal? It's been there. I mean, imagine Elon Musk can create a rocket where the human being trying to pour coal while it's going up in the sky. I mean, he didn't decide to do that, right?
It's an interesting debate. I mean, I think everyone noticed, right? There are a set of mavericks here, and then there are a set of rationalists here, and it's a debate between mavericks and rationalists. So thanks. Thanks for that. It's very interesting. I think this entire debate was about how much can algorithms do, right? I mean, if I summarize that, can they run on their own? Can they heal on their own? Can they fix their own? And what is the limit that we want to take this to? Soma, you spent a lot of time on algorithms, and you have your experience around the telecom industry and with NVIDIA now.
Yeah.
NVIDIA has been at the forefront of GPUs and algorithms. What's your take on what is the state of algorithms today?
For a while, I thought I'm just going to sit here and watch these guys talk. So it was an interesting debate. I would add one thing before I start talking about algorithm. When we talk about data, it's not any data. It's a labeled data, a data that machine can understand and infer upon. That's not readily available. I'll take an example of telecoms. There's petabytes of data telecom operators have. But is it actually computable by an AI? Is it labeled? Not necessarily. So one of the things is you need to have labeled data. We've talked about it. I'm going to move on to the algorithms. Algorithms, I do agree with Muddu that it's moving very fast. If you look at the progress that's happened in algorithm in the last 3 years, it's amazing. And software is writing software. That's a fact. We got to get comfortable with that. The multiple deep learning techniques out there called generative adversarial networks, GAN. It's basically competing against itself and finds the best way to solve a problem. So you have two models, one trying to beat the other, and they actually figure out a way how to work, get the best out of both. So is autoencoder. So you throw the problem out, and actually the system, the machine actually learns and creates its own code, right? So autoencoders are out there. So some of the things that Muddu is talking about is already available and starting to happen. So you don't sit there and design a logic. You actually create a framework which then takes its own life of its own, right? It's more like teaching a kid how to walk and learn, and then it starts to progress itself, getting smarter. And that's the difference between intelligence and logic, right? So the question I always ask is, if anybody says I'm doing deep learning or AI or machine learning, I usually, you can decipher it in 2 or 3 questions. First question, if you write a set of software and if you feed it with more data, does the software get smarter? If the software stays the same, then that is not machine learning or AI, right? Simple as that. Second is the kind of algorithm they use. There are standard set of algorithms for machine learning and deep learning. And those algorithms are a representation of, is it an AI or machine learning or deep learning? So that's the second one. And third is, what kind of data is it, right? The accuracy, what is the accuracy that's coming out of it? Is it comparable to a human? So we definitely have to be looking at software is writing software. The whole new mindset is, how do you get data? How do you get accurate data, clean data? And how do you facilitate this learning? How do you get frameworks that learns and facilitate the learning? It's more about that than about writing software logic.
So I agree with some of the things, but I'll tell you where not disagreement, but a different view also on this one. He talked about the whole idea of labeling the data. Obviously in machine learning or any data science, you got to label the data. But there is an industry that I got involved around 2014, cybersecurity. You can't label your data. You don't know when Russians and Syrians are in your environment. You guys are watching all the news. You can't even come to a conclusion. So how are you going to apply machine learning in cybersecurity? It's the most hardest problem. You don't know how long the attacker is there. He's sitting there, he's browsing through your network, downloading the stuff. So that whole area, there's a whole class of algorithms most of people might have heard called unsupervised machine learning. How do I do an unsupervised machine learning without labeling the data and able to also separate signal to noise? The algorithm itself should train that this actually a behavior is actually a wrong behavior. I have to delete that, right? I see this is an adversary behavior versus a good attacker behavior or a bad attacker. So there are a whole class of algorithms are built without labeling the data, right? On the vision side, when Google and all these guys did on a image processing, it's much easier problem. When you show a cat, it's a cat. Once you label it, whether the cat is standing or sitting down, you can easily guess that. But as you go into the other areas, particularly cybersecurity, or like even I'll talk about areas called like like cloud operation, like Amazon talks about, or Google Cloud or Azure. You don't know when the operations are going down. It's not like at 90% CPU threshold system is working or the application is performing. There are situations where you cannot guess the system. You are in a state at which you cannot guess the system is good or bad. You're not going to have, you never would have seen that state of the system. So you're not going to capture million state of an application and say, I'm going to label it. It's physically impossible. So the labeling approach does not work in many other industries.
Yeah.
So in that case, what are you going to do?
I'll add one thing. First of all, the RF engineering, which I'm close to, is the same thing. There's a whole bunch of signal spectrum interference that it's always moving. It's never the same target. I guess labeled data means it doesn't mean it has to be done by human. Even deep learning systems can start labeling data. That's the whole concept of auto encoding, right?
Yeah.
So even that process can be automated.
Sure.
Yeah.
And both the examples that you talked about, I mean, this is the classic case of the platform or the environment is built in a way that there's a whole lot of data that is captured, and as what Soma has been pointing out, it's sort of classified automatically for the algorithm to actually make sense out of it.
It's not.
It's part of the.
No, it's not. Like in cybersecurity, it's not. You may have a lot of data. You don't even know what data is actually classified, or even you can't, system itself cannot label. But there is a way to do it, whether you call it classification or not. All I'm saying is basically algorithm itself should, while training, should drop certain nodes or certain behaviors. So it's a behavioral based training versus you accept your data and say, I'm going to take this, I'm going to classify it, etc. So there's a statistical probability way of doing things. There's a state space way, we call it Markovian algorithms. There's a behavioral algorithm. All I'm saying is there's a new class of unsupervised Markovian state space behavioral algorithms, which are very, very small niche of algorithms, but they can solve very epic problems. That's what I'm trying to point out.
You know the dirty secret of data scientists? You know, data scientists spend 80% of their time preparing data and 20% of their time complaining about preparing data.
That's true. Yeah.
I mean, we are absolutely. I mean, we are talking so much about data, right? And you know, Siddharth, to use the question to you, you know, a lot of companies think, you know, they have a lot of data, and you know, they're already doing a lot of analytics on that data. And you know, so some of them, you know, may have a feeling saying that, you know, I'm already doing analytics, I'm seeing patterns, you know, I'm getting results, I'm able to, you know, relate it to an ROI, which I'm able to show my profits, I'm able to understand my customer better. You know, when do they take that leap from, you know, from moving from data analytics to, you know, something like machine learning? I mean, is that leap required? You know, is it compulsory in this world today? What are your thoughts about that? And you've done that in Intuit, so you know, you always had data analytics, but now you were in ML. So if you could give me some experiences around that.
Yeah, so I think of them as being somewhat complementary. We actually do need the traditional analytics. You know, if you're looking at your business metrics, for example, you know, traditional metrics do fine. The thing with ML is, you know, and the way we think about it is, what you get with traditional BI is what has happened. Yeah. And when you want to make the leap to what is going to happen or try to predict it, that's when it comes in. So for example, in a lot of our business metrics, we apply things like DuPont models. I don't know if you guys are familiar with DuPont models. Yeah. So with DuPont models, you know, we are in what we try to do is predict what outcomes are going to come. You know, we kind of talked about you know, operations and how much time we spend. So for example, one of the things we do is, you know, incidents. You know, if you know, systems have certain failures, you know, can we actually predict that? So there are actually algorithms that we use, ML algorithms, which actually analyze the data and actually look at it and predict that there is X percentage probability that a certain event of certain magnitude is going to happen certain point in time. So to me, that's the continuum which is built. You know, there is a backward-looking view, which traditionally is done by the business intelligence side of things, and then there's the forward-looking thing, which, you know, we are having varying levels of success with. You know, so in some cases we have been pretty successful in predicting what might actually happen and predicting system behavior. Let it be business models, let it be, you know, software systems, where we are actually applying ML.
So I'll add to that.
Sure.
If you if you're married to your spouse for 20 years. And then you realize that your marriage didn't work out, that's analytics. If you meet your mother-in-law for the first time and you know the marriage is going to work out, that's intelligence, right? So being able to see ahead, I do agree with you on that. So it's very important that.
And I hope your marriage.
He's not recommending anything, by the way.
It's up to you.
Soma, just to let you know, this is recorded. Your wife is going to see it.
Yeah.
And it's too late.
It's too late.
Yeah. So I think there's definitely the horse for the course, right? I mean, we need to see reports. We want to do even today in machine learning, because some of these deep learning networks, it's making biased decisions. We don't know why it made certain decisions.
So I'll give you a different, I mean, I agree with both of them on this one, but I'll give you a different opinion on what's happening in the analytics market. If you look at big data analytics market, it's pretty much dead. From an investor's perspective, both Wall Street and Bay Area, if you have mentioned analytics or big data, you're pretty much dead woman or men walking in the valley right now, or anywhere in the world. Like even Gartner removed Magic Quadrant for big data. It doesn't exist as of 2015 or 16.
That's
right. I'm just telling you facts. So yeah, you can use analytics to look backwards or look whatever you want to do. The idea is where the world is going towards is the reason you have made this analytics is for us to feel good. Looking at those charts and this Tableau charts to say, hey, trends are up and down, for us to feel good. But once you have the decision, what people want is the decision engines, recommendation engines. Once you have those things working, they don't want to look at the chart. That system is going to make a decision. So do you think Google has made $100 billion having any BI reports? Google AdWords, etc. doesn't ever had a UI. It's placing an ad, whether you like it or not. When you go to New York Times web page, it's going to give you a diapers ad, whether you're buying diapers or not. Sometimes you click, you don't click. That's it. So there's no decision engines there. There's no analytics to even the advertisers. If you go to any advertiser and say, do you think Google ever give you any kind of KPIs or anything? There's no. I mean, all they say is how much you're spending. Your spending is generating revenue or not. That's about it. There's no charts. There's no tableaus. Any of those things. So my point there is, this whole analytics was on the way to build real system, real decision engines. I think the world is catching up to that. It definitely happened in the e-commerce industry, in the ad tech industry. After that, everybody woke up. They're applying to every other industry. Whether it's financial fintech industry, your cars will applying to self-driving cars or autonomous cars. You're going to apply that into IT operations cloud. So I think this whole idea of analytics and this is just a stop game. Eventually, people wanted automated decision engines, and people will look at false positives, false negatives. You'll do all your analysis, but analytics and BI is just a small. At this point, the chapter is going to pass.
Fantastic.
Thank you.
Thanks, Muddu, Soma, Siddharth, Sunder. Thanks so much
Thank you guys.